So like I said, 5, 6, and 7 are all going to be your last test. So it'll take us about a month to get through these 3. So middle to end of April, we'll be doing that last test. 5, 1 is going to be a 2-day lesson. So we'll do like 15 minutes, 20 minutes at most today, and then about the same tomorrow. We'll divide it up. You guys will have some time to work on your Math Excel. Okay, so first definition, we're going to talk about our normal distribution. This is our bell curve that we've kind of been referring to, okay? So when we talk about our probability distributions, we have now a total area under our curve equal to 1. So that's the sum of all of your probabilities. That's where that comes from. Pieces of information you need to know about this distribution. Number 1, the mean, median, and mode are all equal, and they are all where that mean is located in the middle of the bell curve. Okay, so it's your center point. You can drop it down, and you can find all 3 of them. Yes. What's the Math Excel due? This Math Excel is due on Friday night. Friday night. All right. Yeah. Okay, it's bell shaped. It's symmetric. Again, total area under the curve equal to 1. Make sure you highlight that. And it never touches the x-axis. Everything is actually above the x-axis here. So think of the x-axis or horizontal axis as like an asymptote that we're approaching on the left and the right there. Okay, so all my values are positive, never touches the axes. Okay. All right, from this normal distribution, we can find, using inflection points, our mean and our standard deviation. So the mean, we know, is just, again, that center point drop down. Inflection points are when the curve changes from, if you've taken like calculus, talk about concave up and concave down. Does that sound familiar? Maybe to some of you. If you haven't taken calculus, think about it as on the sides we've got an exponential function, and then it changes at some point to like a parabola that opens down. Okay, so opening up, and then at a certain point it becomes something that's opening down. That's what we call the inflection point. Okay, if we take the inflection point on our curve and drop it down, the distance between the mean and that value that we find gives you the standard deviation. And these little standard deviation formulas, we saw those before a couple chapters ago, right? We can go 3 standard deviations to the left and to the right. 68% of the data is between 2 of them, so on and so forth. Okay. All right, so the first thing we're going to practice is just finding the mean and the standard deviation from these curves. Okay, so looking at the first one on the left here, can you tell me what the mean is? 3.5. Okay, and they've drawn in the inflection point here, so you can just drop it down to your axis. The distance between the mean and where that inflection point came down is going to give you your standard deviation. So you can look on either side of the mean here, on the left or the right. So approximately, what's the standard deviation here? About 1.5. Yep. Okay. All right, what about the one in the middle? What is the mean? About 3.5 again. And if I take those inflection points and drop them down, approximately, what's my standard deviation? About 1. Okay, so comparing the first and the second graph there, they have the exact same mean, but my standard deviation got smaller. So look at what happened on that curve. The smaller my standard deviation gets, the more clumped together the data is going to be. So you're going to see a lot taller of a curve versus if my standard deviation is bigger, like 1.5, it's going to be a lot wider. It's going to be more spread out. So you're going to see a flatter curve. Okay, the last one, what's my mean there? 1.5, and then what's your standard deviation, approximately? I would say it's close to 1 again. Again, we're approximating, so there's a little room for error there. Okay, so comparing like B and C now, they have the same standard deviation, but the mean is changed. So if you look at those two curves, they have the exact same shape, same width. All that's happened is my curve has shifted left or right to wherever the mean is located at. Okay. So from this picture, can you tell me which curve, A or B, has a greater mean? A has a greater mean because it's further to the right on my axes. Which curve has a greater standard deviation? B has a greater standard deviation because my data is more spread out, it's wider. What's the area under each of these curves? The total area is still equal to 1, okay? So all that's happening is this area of 1 is being spread out or pushed closer together depending on where my standard deviation and my mean are. Okay, so let's put it all together now on this one. So here we have a scaled test score for a math test. This is the New York State Grade 4 Common Core math test. We are told that it is normally distributed. We're going to start looking for words like this in our problems. You need to know that things are normally distributed to be able to use a lot of the formulas that are coming up. The normal curve represents this distribution. We want to find from this curve the mean test score and the standard deviation. So what do you guys think? What approximately is my mean test score? You can draw it on yours if you need to. I'm going to say it's a little bit more than 300. I'm going to say 305 for that one. Okay. I would say approximately equal to because we're estimating. Okay, so now on this one, we don't have the inflection point. We want to find the inflection point. So again, what we're looking for is where this curve changes from increasing to decreasing, or not increasing, decreasing, concave up to concave down is where I want to use. So it's going to be close to the middle of the side of one of your curves. Usually it's a little bit closer to the top of the hill than the bottom of the hill if you're not sure. So do the best you can as far as estimating that goes. I'm going to say maybe about there. Now, because it's symmetric, once you find one inflection point, you can draw a horizontal line to get your other inflection point and then drop them both down. Okay. And again, either one, left or right, that distance is going to give you your standard deviation. So about, let's see, that one on the right maybe is like 345 is where it's hitting. So what's my standard deviation then, approximately? About 40. Okay, and again, there's a little room for error there, like this one. If you were within like 5 of that, if you said between 35 and 45, that'd be fine. Okay, make sense? Okay, you guys try these 3 real quick. Okay. B and C for numbers 1 and 2. And then number 3, again, that's approximately, looks like 3,300 is about in the middle, maybe 300-ish. Okay, if you're within like 100 of that for the standard deviation, that's okay. Yes?
Without inflection points, where do you decide, like...
You have to estimate that inflection point. You need the inflection.
So like I said, like 600 for the standard deviation.
So 600 is quite a bit.
That's
pretty far over here. Yeah, you're going to be close.
2,700.
Oh, it is 600 then. I was reading it wrong. Thank you. I don't know what I was doing. It's more like 600. Thank you. Yeah?
How do we know exactly where to put the inflection points?
So they're going to be on the middle of the side of the hill, but they're going to be a little closer to the top. I mean, that's estimate. A lot of times when we do problems, you're not going to have the graph defining the mean and the standard deviation. We're going to most of the time be using that backwards. We're going to have the mean and the standard deviation, and then be making the graph or answering the question with it. Yeah.
But math XL can really kind of lead with that, or?
Yes. Okay. Or they'll give you the inflection point, so you'll be able to drop it down. Yeah. Okay. Other questions you can answer with that guy on the left there, A, B, and C. Can you tell me which 2 curves have the same mean? A and C have the same mean. Their top of their hill is in the same location. Which graph has the smallest standard deviation? A has the smallest standard deviation because you've got a taller hill. It's all clumped together, all your data's clumped together. Okay, good. All right, last problem we're going to do today, you need a graphing calculator for. So if you guys want to take that out for me real quick. I'm going to show you how you can get a normal curve graph on your calculator. So what you need to do, our plot actually needs to be off. I don't know why the plot is highlighted in this picture here. So we're going to go to y equals, and just make sure your plot is off, and then make sure your y equals is empty. Okay. Plot off, y equals empty.
What is it off?
It's off if it's like mine on my calculator there. It's unhighlighted. So not like the picture on your screen. You don't want the box around it. Okay, so we're going to go back into the distribution menu. We use this a little bit. It's above the vars button. So you're going to hit second vars. Okay, and normal PDF is what we're going to choose. Okay, so I'm going to hit enter. And it's going to ask you for 3 things. Now, we can use this to calculate stuff. So sometimes an x value, you'll actually put a number in there. For graphing purposes, we just want to keep it an x. So for the first row, put an x in, just your variable button that you guys always use next to alpha. And then we're going to use the numbers that you see on the screen here. So the mean we're going to use is 305, or whatever data set this is. And then the standard deviation we're going to use is 40. Okay. And then when you hit paste, it'll show up in your y equals. Okay, then we're going to graph it. Now, the graph, there's not like a great, we tried Zoom Fit first period, and that didn't really work so well. So we're just going to go to Window and adjust this ourselves. So your x values, imagine having a mean at 305 and your standard deviation is 40. Okay, so 305 is going to be the middle of our graph for our x values, and then maybe we'll give it like 200 in each direction. So let's say my x values are going to be 100 to 500. Okay, so x min 100, x max we can say 500, x scale, that's just how often you see a tick mark, so you can put whatever you want there. You can put like 50, or you can just leave it at 1. It won't hurt anything. Now the y values, remember the total area under the curve is 1. So if every data value is exactly the same, the highest this curve is going to get to is 1. And the lowest it's going to get to is 0. And that's really like overestimating it. So your y values are typically going to be a pretty small number. So y min, put a 0. Y max, you could start with like 0.1 if you want. And then you could always make it smaller than that if you feel like it's too tall. So if you hit graph, okay, so like that's pretty tall. I feel like I've got a big gap at the top. So if I go back, I can change my y to a little bit smaller of a number, like 0.01. Okay, and that gives me a little bit better picture of it. Okay, so here's the settings I use there. Drag that over. Yeah, there's the window settings I had. Okay, so it does involve like playing with it a little bit. Zoom Fit doesn't really give us a very nice picture, so you got to kind of do that by hand. Okay. All right. Yep.
Alright, so like I go into my y equals and I do the bar stuff and it doesn't like take me to the.
Did you hit second bars?
It doesn't like no watch how like I'm showing you there. I click normal PDF and it takes me back to y equals. Is that what it's supposed to do? Go out of that? No, like chart. You were in the equal chart now.
Were you hovering over the equals?
Yeah, I have that.
Well, there it goes. Okay, you got it. All right, that's actually all we're going to do with 5.1 today. Okay, so we're going to stop there. You guys can use the rest of the period to start your Math Excel for 5.1. That Math Excel is due on Friday night. Tomorrow we're going to do the second half of 5.1, which is involving finding like areas under our curve, and we're going to use the table of values you guys got in that packet today. So keep that guy handy. We're going to be using it a lot on problems actually for the rest of the year. Okay. Any questions for me, calculator or otherwise? Alright.
How do you figure, oops,
Yeah,
sorry.
go
How
ahead.
do you figure out the window? Is that just like different for every
You just
question?
play with it. Like this one, I knew my mean was 305, so I know that has to be the center of my x values. And then my standard deviation was 40. So you could add, 3 or 4 standard deviations in either direction, and that's your x. The y's are going to pretty much stay the same. Those won't change too much because your height is always going to move between 0 and 1. Okay.
Oh, I use this thing.
All right.
My math Excel, I probably someone said.
Yeah, absolutely. Go for it. As long as you remember your password, you're good.